Carbon, nitrogen, oxygen, and fluorine obey the octet rule rigorously. Other atoms, not so much. In fact, I don't really like to call it the octet rule at all. I really prefer the octet suggestion because it turns out that some atoms can accommodate more than 8 electrons, while others are pretty happy to have less than an octet. Some molecules also have an odd number of electrons. Those are called radicals, and you'll experience those a lot in your organic chemistry classes. We won't focus on those in this class, but we will see several examples of molecules with what we call an expanded octet, as well as those that have an incomplete octet. But always keep in mind that in this class, if you draw a structure that has carbon, nitrogen, oxygen, or fluorine without an octet, then it is incorrect. Some atoms can have more than an octet. We call this an expanded octet, and we mean that they have more than 8 valence electrons. We used to think that this was a result of having empty d orbitals and using d orbitals to expand the octet. We now know that that's not actually true, and we don't need to worry about how an expanded octet occurs. It's a little bit complicated. But what we can remember is that any element that is in row 3 of the periodic table or below that may have an expanded octet. They don't have to, and they don't always, but it is permissible. Let's look at an example of a molecule with an expanded octet. We're going to draw the Lewis structure for the I3 minus 1 anion. As always, we'll start with a valence electron count. Each of the 3 iodine ions has 7 valence electrons for a total of 21, and then our -1 charge is the result of the addition of 1 more electron, so our overall structure has 22 electrons. The next step is to identify the central atom, and in this case the only type of atom present is iodine, so it will be our central atom. I also went ahead and connected each of the additional iodine atoms to the central atom with single bonds, and this process used up 4 electrons. This leaves me 18 electrons to deal with in the rest of the structure. I'll begin completing the octets on the outer iodine atoms. 2, 4, 6, 8, 10, 12. Now both of the outer atoms have complete octets, and I have 6 electrons left to deal with. I can put 2, 4 on the central atom, and this gives the central iodine atom a share of 2, 4, 6, 8 electrons, and means that I now have used up all but 2 of the electrons in my valence count. All 3 of the iodine atoms have a share of 8 electrons. They all have a complete octet. So when this happens, when everyone has a complete octet, but we have leftover electrons from our valence electron count, those additional electrons always go on the central atom. In this case, that results in an expanded octet on the iodine. It now has a share of 10 valence electrons as opposed to 8. Note also that because this is an ion, I did put the entire structure in brackets and put the charge on the outside.